In this lesson, we'll investigate how the evolution of one trait or one behavior in one species can influence the evolution of a separate species. And when the changes in one species influence another species, biologists call this an evolutionary arms race. The example we'll use again is the case of the cuckoo bird. Now, we've already learned that cuckoo birds victimize warblers. And in fact, here we see a warbler nest, lots of warbler eggs, but one of them is a cuckoo egg. In fact, it's so hard to tell here, it indicates that the cuckoo egg has what we are going to call good egg mimicry. So the cuckoo egg looks just like the warbler eggs. But for robins, it's a different story. Cuckoos do sometimes victimize robins, but the cuckoo egg does not look as much like the robin egg as the warbler egg. And sometimes cuckoos also victimize dunnocks. The dunnock eggs are the blue-green eggs here. The cuckoo's egg here stands out significantly. So we're going to try to understand, well, why the difference here? Why do cuckoo eggs look a lot like warbler eggs, a little bit like robin eggs, and nothing like dunnock eggs? And the answer will have to do with evolutionary forces, natural selection, and this idea of an evolutionary arms race. Now, a quick reminder of the situation with the cuckoos. The cuckoos, the female is depositing her egg in a warbler nest, or another, could be a robin nest or a dunnock nest, and then we'll eat one of the eggs, and then the cuckoo chick hatches first, and then engages that amazing instinctual behavior of ejecting all the eggs. And from the host species, if you think of the cuckoo as the parasite and the other bird as the host species is clearly a loser in this situation. They will feed this chick that is from a totally different species. So the cuckoo succeeds when the other bird, the host species, feeds its chick. If we think about sort of countermeasures to the cuckoo's parasitic lifestyle, we could imagine that if the host species could just simply recognize the foreign egg and then do something about it, whether destroy it or abandon the nest and make another nest and lay new eggs in another nest, well, then that would be an advantage for the host species. So we're going to follow up on this line of thinking and see whether we can understand the pictures that we saw earlier in terms of an evolutionary arms race. Now, the story we're about to tell in the next couple of slides is the story of warblers. And you'll recall that the warblers make eggs, and the cuckoo egg here looks very close to the warbler egg. So the cuckoo has a high egg mimicry in the case of warblers. So the story we're about to tell here is the case of the cuckoo and the warbler, and then we'll try to understand why it is that the cuckoo eggs look a little bit less like robin eggs and then nothing like the dunnock eggs after we understand the warbler case. Okay, so once upon a time, there were cuckoos that made an honest living. Cuckoo parents laid eggs in their own nests and cared for their chicks. But then some cuckoo mothers began dropping their eggs into warbler nests. We suspect that a change in DNA causing a change in their brains caused these adventurous mothers to explore a new way of living. When there is variation in behavior, and that variation makes a difference to survival, we have a situation where natural selection will operate. If the parasitic mode of life resulted in more chicks surviving to adulthood, the new mode of life would be favored by natural selection. In time, more and more cuckoo mothers would be putting their eggs in warbler nests. Now consider the fortunes of two cuckoo chicks. And here they are here, these two cuckoo chicks. Whichever chick had a greater tendency to eject warbler eggs will have an advantage. They will get more food from the warbler parents. Again, when there is variation in behavior and that variation makes a difference to survival, we have the conditions for natural selection to operate. In this case, natural selection favors those chicks that eject warbler eggs. Some chicks eject eggs more than others because of differences in their DNA, which builds their brain. Over time, egg ejection becomes an instinctual behavior in most cuckoo chicks. And we saw this in a previous lesson. Go round and around this diagram here, and we install the egg ejecting behavior. With foreign cuckoo eggs in their nests, warbler parents were in danger of losing their own offspring and raising a cuckoo. The ability to recognize one's own eggs would be a defense against the cuckoo's tactics. Suspicious warbler parents could abandon the nest and start a new family somewhere else. Those warblers with better egg recognition were favored by natural selection. Again, we must have variation that makes a difference to survival for natural selection to operate. And again, changes in DNA that builds the warbler brain would explain why some warblers had egg recognition and some didn't. So here we see a warbler that could not recognize the cuckoo's egg. They are at a disadvantage. They will lose the struggle for existence. Warblers that can recognize the cuckoo egg have an advantage. Cuckoo mothers now faced warblers with better and better defensive behavior. Egg recognition was a threat to cuckoo survival. In fact, egg recognition began selecting cuckoos for better egg mimicry. In other words, those cuckoo mothers whose eggs happened to be a little more similar to the warbler eggs had an advantage. And again, differences in DNA would explain why cuckoo eggs have more or less egg mimicry. Their chicks would have a greater chance of survival since the warbler parents would not abandon the nest. So now let's return to the puzzle of why is it some cuckoo eggs look a lot like the host species, less like, and then nothing like the host species. If we actually plot egg recognition versus egg mimicry in the cuckoo, so this is egg recognition in the host species, we find an interesting correlation. So it turns out that warblers have really good egg recognition. So they have the capacity to spot eggs that are different from their own, and they will destroy it or abandon the nest. Robins don't have such a good ability, and dunnocks have virtually no ability to identify a foreign egg. And so we can understand this correlation then, why it is that some species with good egg recognition, those are the species where the cuckoos have really high egg mimicry, and why those species that don't have very good egg recognition, the cuckoo eggs look nothing like the host egg. We can understand that in terms of natural selection. So let's take the dunnocks. Here the idea is that cuckoos have only recently started to victimize the dunnocks. And so the cuckoo egg looks nothing like the dunnock eggs, but that's okay for the cuckoo because the dunnock parents cannot recognize that foreign egg. So it's as if in this story that we told about the warblers, it's as if the dunnocks are recent victims of the cuckoo. So they're still in this stage. They have not yet evolved a countermeasure of egg recognition. For the robins, the idea here is that the cuckoo egg has some mimicry with the robin egg, but it's not as good as the warblers. But here the idea then is that cuckoos have been victimizing robins for a longer time. And so robins are in the process of evolving egg recognition, and that forces a selection pressure on the cuckoos. So the cuckoos have been evolving better egg mimicry in response to the robins evolving better egg recognition. And then down here we have the warblers. The warblers are way up here on the graph here. They have evolved good egg recognition precisely because they have been a long time victim of cuckoos. So Cuckoos have been around a long time victimizing warblers, and in response to that victimization, warblers have evolved good egg recognition. But a countermeasure to that was egg mimicry in the cuckoos. So the warblers are down in this lower portion of the diagram. They have been engaged in an arms race with the cuckoos for a longer time than the robins and the dunnocks.